half of lesson 1D is talking about rationalizing denominators. We've already learned how to divide radicals, but now the big thing we're talking about is rationalizing denominators. So that's a big word we need to look at. So here's a rule. We do not want to leave our radical as an irrational number with a radical in the denominator of a fraction. To change it to a rational number, we need to rationalize the denominator of any fraction. So basically, any square root sign on the bottom, or cube root sign, whichever it is, any radical on the bottom cannot be left on the bottom if it's not a perfect radical. So, in order to rationalize our denominator with a radical, we multiply both the top and the bottom of the whole radical by the bottom radical itself. Okay? Now, not the coefficients. We just multiply it by the actual radical itself. Any fraction with an identical top and bottom will equal to 1, which is why we could actually do this. We're not changing the value of the original expression. We're just actually multiplying it by the number 1. Now, remember, we need to simplify our final answer into a lowest mixed radical. Always, always. We always have to simplify as our last step. So, what that actually means is, if we have coefficients, we need to simplify our coefficients into lowest term fractions and not decimals. So, is it okay to have a radical left on the top? Absolutely. We can leave radicals on the top, just not on the bottom. Okay, let's check and see how this actually works. Here's an example. So it says, to be in simplest form, the denominator, the bottom of our fraction, should not be irrational. But what do you mean irrational? We have to remember what irrational numbers are. Irrational numbers are any number that is a non-perfect square root, okay, or non-perfect radical. So if it's a non-perfect radical, it's going to give us a run-on decimal. We can't leave those in the bottom of any fraction. So how do we actually simplify that? Well, in the steps and the rules, it told us that we take the radical on the bottom and we multiply it to the top and the bottom. So if I take a look at this, root 2 over root 2, if I take root 2 divided by root 2, I get 1. So is multiplying something by 1 changing the value? Absolutely not. So that's why we're able to do this function. So when I do this, I'm going to get 1 times root 2 is just a hidden 1 in front of root 2. Do you need to draw the 1? No, you don't. Then I multiply my bottoms. I'm going to get root 2 times by root 2. Well, that's going to give me root 4, which is 2. So now you're going to notice there's no radical left in the bottom of my equation for my fraction here. And that's what I'm looking for. I do not want to have a radical left in the bottom. That's the whole point we're trying to do here, is get the radical off the bottom. I still have one on top, and yes, that's okay. Let's try some of these together. All right, let's take a look at this first one. What number do I have to multiply by? I actually have to multiply the top and the bottom by root 5. So I put a root 5 out front and a root 5 out front. So I'm going to do the top here for us. When I do the top, I can put it into an area box. It'll just be a 1 by 2 box. So I'm going to have root 5 out front, and on top I'm going to have 4 root 5 and negative 2. And again, remember, we've got a hidden 1 in front of our root 5 that we're multiplying. So, I multiply coefficients. 1 times 4 is 4. Root 5 times root 5 is root 25. Now, I actually solve root 25. Root 25 is 5. So then I get 4 times 5, which actually gives me 20. So when I multiply the first two, it gives me an answer of 20. The radicals completely disappeared. Is that okay? Absolutely, it's okay. The next box here, I'm going to take the negative 2 and multiply it by the 1 in front of the root 5. It does not multiply to the actual root 5 itself. So we've got negative 2 multiplying by the 1 to give me a negative 2, and the root 5 just tacks on beside because it's attached. So my final answer for this, on the top, my top is going to become 20 subtract 2 root 5. That's what my top gives me. Let's find out what the bottom gives me. When I do the bottom, this is what happens. Okay, on the bottom, I've got root 5 times by root 5. Well, that's going to just give me the root of 25, which is a perfect square root, and I can solve it. So that's going to give me a 5 on the bottom, which is wonderful because now my root sign has disappeared. So I write my final answer. I put my top, what I found earlier, the 20 subtract 2 root 5 on top of my bottom that I just calculated, which turned out to be a 5. That would be my final answer in simplest form. Now, I know it's in simplest form because I'm going to check a couple things. The 5 does not have a radical with it. He'd be considered a coefficient. So what we've got, well, not really a coefficient actually, he's a constant. But because of that, he doesn't have a radical, he can only divide into the ones that do not have radicals. So he can divide into the 20 and the 2. Now, do I do the dividing if he only divides into the 20? No. The 5 on the bottom can only reduce if he divides into all of the numbers on top except for the radicand under the root sign. So I know he's going to divide into the 20, but he does not divide into the 2. So he has to divide into both for me to reduce it. That's how I know he's already in the reduced simplest form, because he does not divide into 2 evenly without giving me a decimal. So this answer is completely finished. That is what it would look like. Let's try B together. Now on B, you're going to notice I've got a root 12, but root 12 is not in simplest form. So I need to reduce it before I can get rid of my bottom denominator. So I know he is root 4 times root 3, and I know the root of 4 is 2. So I get 2 root 3 as my bottom. So I rewrite my expression. I have 9 root 2 minus 3 root 5 on top. On the bottom, I've got 2 root 3. Now, when you've got a coefficient in front, you don't actually have to do the multiplying with the coefficient. You just multiply the top and bottom by the actual radical. Okay, so now I'm actually just going to multiply my whole top. And yes, there's more than one thing, so I must put it in brackets. I'm going to multiply my whole top only by the root 3. Same as my bottom. I'm going to multiply it by the root 3. Let's move this over a little bit. See? So I'm going to put root 3 out front and multiply my bottom also by root 3. Okay, so I can do a box for my top. My top is root 3 timesing by 9 root 2 minus 3 root 5. Now let's do our actual multiplying. So since there's a hidden 1 out front here, he times this by the 9 to give me a 9. Root 2 and root 3 give me a 6. So I have 9 root 6. Negative 3 times 1 gives me a negative 3. Root 5 times root 3 gives me a root 15. So my top simplifies to 9 root 6 minus 3 root 15. Okay, let's see what our bottom gives us now. When I multiply the bottoms, I'm going to have root 3 times 2 root 3. Well, there's a hidden 1 in front of this root 3, so the 2 and the 1 are going to multiply, and the 3 and the 3 are going to multiply. So the bottom is going to give me 2 root 9. What do we know about root 9? It's a perfect root. So I'm actually going to get 2 times 3 to give me 6. So now I have a 6 on my bottom. When I take a look at that now, I check and see, is it in simplest form? It's only in simplest form if the numbers out front of my radicals and the bottom number divide evenly. If they don't divide evenly, they are in simplest form. Well, I know the 9, 3, and 6 will all divide by 3. So I'm going to do reducing. I'm going to divide them all by the 3. I don't actually have to divide by the 6 that's on the bottom. I can divide by one of the factors of the numbers. So I can divide them all by a 3. That's how I reduce my expression. So my final answer is going to be 3 root 6 minus, I have a hidden 1 now, root 15 in front of my root 15, and my bottom number is now going to become a 2. This would be my final answer in simplest form. Now, would it be wrong if I actually multiply the top and the bottom by 2 root 3 and 2 root 3? No, it wouldn't have. It just means that when I get to my very last step right here, it just means that I would have had to divide. These numbers would have been bigger, and I would have had to divide to make them smaller. They still reduce to give me my final answer of what I found. Okay, let's move on to section B here. That was letter B. So we're going to do letter C now. Sorry. So let's take a look at letter C. Everything is in simplest form when I take a look at them. They are all broken down. So my bottom is broken down. I'm just going to multiply both my top and my bottom by root 3. Okay, I need to multiply top and bottom. So this is what my top is going to become. Root 3 times, in my box, 4 root 2, and then I've got a negative 6 root 5. When I multiply my coefficients, 4 times my hidden 1 gives me 4. 3 times 2 gives me root 6. Negative 6 times 1 gives me negative 6. Root 5 and root 3 give me a negative root 15 when I multiply them. So now that is what my top reduces to. So my top becomes 4 root 6 minus 6 root 15. Now I'm working on the bottom. My bottom is going to be... My bottom is going to give me root 3 times 2 root 3. Well, the 2 is multiplied by the hidden 1, so that's going to give me 2. Root 3 and root 3, like last time, gave me root 9. But the root of 9 is an exact digit. It's 3. It's a perfect root. So now the 3 multiplies by the 2 that's already in front, and I get a 6. So now my bottom number is 6. Again, I'm going to check my numbers in front of my radicals. Do they divide evenly by the number 6? No, they don't. But they all evenly divide by 2. So I'm going to divide all of those numbers in front, my coefficients, and the bottom by 2. That's going to reduce it all for me. So my final answer is going to become 2 root 6 minus 3 root 15 all over 3. My radical is off the bottom. Everything is reduced. That's my final answer. On the next page, you've got a few examples to do. So do the examples, push pause now, and play when you're ready. Okay, got a couple minutes to look at it. Let's take these up together. So we're going to multiply this whole top by root 5 and the bottom again by root 5. So my top becomes root 5 multiplying by 2 root 5 and positive 4. Doing the multiplying, I'm going to get 2 root 25, which will give me 2 times 5, because root 25 breaks down into 5, and that's going to give me 10. Then, left over, I take 4 times by the hidden 1 in front of the 5, and I get 4 root 5. So this is going to give me 10 plus, because it's a positive 4 here, 10 plus 4 root 5 is my top. Now let's simplify our bottom. On the bottom, I've got root 5 times root 5. That's going to give me a root 25, which solves to be exactly 5. So my denominator, my bottom, becomes a 5. Now, again, my last step is to check the coefficients. So I check the 4, and I check the 10, and see if they divide by the 5. Okay, the only factors of 5 are 5 and 1. So we have to check and see if they divide by 5. The 10 does. Yes, he divides by 5, but the 4 does not. They both have to divide by the 5 in order for me to break it down into simplest form. So, since they both don't divide, only one of them does, that means it's already in simplest form. So my final answer would be that. Okay, check your work and make sure that's what you got. Let's try B. For B, we're going to multiply both sides, top and bottom, by root 6. So my top is going to give me root 6, and it's multiplying by 5 root 8, and negative 2 root 5. I have a hidden 1 again in front of my root 6. So the 5 is going to multiply by the 1. I get 5 root 48. 6 times 8 is 48. My next one, I'm going to take negative 2 times 1, gives me negative 2. 5 times 6 gives me 30, so root 30. So my top then is going to give me 5 root 48 minus 2 root 30. Now I check my bottom. What's my bottom going to give me as an answer? Well, let's check. My bottom's going to have root 6 times root 6. And what do we know about that? Well, it's going to give me root 36, which is a perfect square. So that's going to give me 6. Are we finding a pattern here? Whenever we multiply a root or a radical by itself, the radical sign disappears, and we end up with the answer that's under the radical. Okay, so whenever you times a number by itself, but under the radical, you can take the radical away and just give you the 6. Okay, so my bottom number is going to be a 6. Now, I check and see, first of all, I need to see if my radicands are in simplest form. Well, 30 is in simplest form, but 48 is not. So I need to make sure that 48 gets broken down into its simplest form before I can check and see if the 5 and the 2 divide by factors of 6. Because currently, right now, 5 will not divide by a factor of 6. The 2 will. They'll both divide by 2, but the 5 won't. But that could change when I break down root 48. So let's break down root 48. Root 48 breaks down into the root of 4 times the root of 12. Then we can break it down again. So root 4 is 2, root 12. Root 12 will break down into root 4 times root 3. A 2 down in front, he slides down as well. So my final answer for root 48 is going to give me 2 times 2 root 3, which is going to give me 4 root 3. Now if we check and we take a look, in front of my root 48 in my original equation there, I've got a 5. I have a green 5. Well, that green 5 in front of my root 48 has to come all the way down, and he's going to multiply by that 4 that I just found. Okay, so now my root 48, or my 5 root 48, is going to become 20 root 3. Okay, so now I'm going to rewrite my question with 20 root 3 on top. Okay, that is what I end up with. Now I check my coefficients. The 20 and the 2 and the 6. Do they divide by a factor of 6? Absolutely. A factor of 6 meaning if I factor 6, the only factors of 6 are numbers that multiply to make 6. So 1 and 6, we never worry about the 1. And then 2 and 3. So I'm trying to see, do my top numbers, 20 and 2, divide by any of the other factors? So do they divide by 6, do they divide by 3, or do they divide by 2 without giving me a decimal answer? They have to divide evenly. Well, we're going to find out they all divide by 2. So I'm going to divide my 20 by 2, the 2 by 2, and the 6 by 2. When I do, I'm going to end up with 10 root 3 minus the hidden 1 root 30. And that's going to be all on top of now 6 divided by 2 is 3. This would be my final answer now. I am done. Why didn't I break root 30 down? Because root 30 is in simplest form. It does not divide by a perfect square. Okay, here's the last question you have to do. And a good rule of thumb is to break every radical down first before you start multiplying. So I'm actually going to break root 12 down and root 18 down. So let's do that first. When I break down negative 3 root 12, the negative 3 slides down, and 12, the root 12 breaks down into root 4 times root 3. 3 comes down, root 4 is 2, and then my root 3 tacks on to the side. I multiply my coefficients, I get 6 root 3. So my top number here, negative 3 root 12, becomes 6 root 3. And that's a negative 6 root 3 actually, because that was a negative 3 up front. Now I'm going to break down the root 18. So I've got a positive 2 root 3 that's still on the top. He's in simplest form. And I'm going to break down root 18. Okay, root 18 divides into become root 9 times root 2. The root of 9 is 3, and the root 2 slides beside it. Okay, so my bottom then becomes 3 root 2. So now what do I multiply my top and bottom both by? I multiply by the actual radicand. So I'm going to multiply by root 2 to the top and to the bottom. That's going to help me rationalize my denominator. So let's simplify our top. Okay, I'm going to multiply my top. I've got root 2 multiplying into negative 6 root 3 and 2 root 3. So I've got negative 6 root 6, and then I'm going to get 2 in front of the hidden 1, multiplied by the 1 to give me a 2 root 6. So my top becomes negative 6 root 6 plus 2 root 6. All on top of what I have on the bottom. Now my bottom is going to become There's a hidden 1 in front of my root 2, so the 3 and the 1 multiplied to give me a 3. The root 2 and root 2 multiplied to give me root 4, which solves to be a 2. So I've got 3 times 2 to give me 6. So my bottom number is a 6. Well, if you take a look at my top numbers, what do we notice? They are like radicals because they both have a root 6. So that means I have to simplify my top still. I'm still not finished simplifying my top. In all the other questions, the numbers under our radical signs, the radicands, were all different, so we couldn't add them together. But in this case, my radicands are the same. So I can break down, or I can simplify it further by adding the numbers in front. So that's going to give me a negative 4 root 6, all on top of 6. Now I see if the 4 divides by a factor of 6. And again, my factors of 6 are 1 and 6, 2 and 3. Both divide by 2. So I'm going to reduce and divide them by 2. That's going to give me negative 2 root 6 over 3. That will be my final answer. We can't go any further. That concludes 1D, Part 2, Rationalizing Denominators.